Hello friends, did you ever notice autoboxing performance related issue in your program? Do you know your IDE can help you find places of autoboxing and unboxing? If you are curious to know about the answer of these questions, then keep watching this video tutorial till the end. Friends, my name is Kanhaiya Chhipa and I run a YouTube channel called Java Interesting Topics. So welcome to my YouTube channel, and today I gonna cover autoboxing performance related issue, and we will be looking at the throughput and memory consumption related issues that could be occurred due to the unwise decision during the autoboxing work. So let us start. Before I start about the autoboxing performance, let me give a real quick introduction about the autoboxing, and then I'll be covering up the performance related issue. So let's start the session now. So guys, you must know that the autoboxing and unboxing has been introduced since Java 1.5, right? And the autoboxing and unboxing, let me take one simple example as of now. And what is the autoboxing and unboxing? So when you see this diagram, when you convert the primitive type to the wrapper type, like the primitive type data types are like int, long, double, float, boolean, and so on. If you convert these into the wrapper type, integer, long, and double, something like that, these wrapper classes, that is called autoboxing. And if you do the reverse, like from the wrapper type classes to the primitive type, then that particular concept is called unboxing. Alright, so let me take a real quick one example related to the autoboxing and unboxing. So for that, I'm taking one list. That list is the integer list, and that is array list I'm taking right now. So friends, you must know that whenever we add any element to the array list, only the objects can be stored into the array list. Primitive types are not supported in that. But from Java 1.5 onwards, if I try to write the program something like this, like in this option itself, have a look at this options. Like I'm adding the number primitive into the array list as an primitive type, but it is automatically converting this one into the wrapper type object. So this code integer dot value of is automatically get appended in your code by the compiler. So auto boxing is happening for you without knowing yourself. One thing I would like to give you the recommendation that never ever add the your integer object something like this, like putting in like new integer I in this bracket in the add method. This is really expensive operation and cause you lot of performance cost. If you want to know about that in more detail, I would like to recommend you to watch my first video session related to this. That is integer wrapper class interesting facts. So I'll give the detail about that video in the description box itself. So if you are interested, what is the performance cost hidden behind this, you want to know about that, you can go there and watch that first. Now coming to the unboxing example, what is unboxing here? So I would like to take the same example, like I have an array list and I have stored one of the object inside that, and I would like to retrieve that object back from the array list. So what I do generally, I write like in the previous example I have stored single object, so I'm getting the same object by placing its index ID. So what I'm doing, I have written like numbers dot get 0. So what it does, it returns you the integer wrapper class instead of primitive type. But the unboxing kind of scenario happens behind the scene for you, and you can automatically convert that particular stuff into the primitive type number. So int number is converted automatically for you, and that concept is called unboxing. So what your compiler does, it inject this code nums.get0.int value for you. So two things you have to write less after the autoboxing, and once the autoboxing and unboxing concepts have been introduced here. So friends, there could be many other scenarios of autoboxing and unboxing where we'll have to be careful, and we can see where the autoboxing is happening and where the unboxing is happening. If you would like to know that uh, your IDE can help you out, what are the cases of autoboxing and what are the cases of unboxing, then you can make some changes in your IDE that I'll show you once the demonstration of the program, and you will get to know that what is going on during the autoboxing and unboxing in your program. So wait for that. Now let's take few scenarios related to the autoboxing and unboxing. I'm going in real quick way for the explanation of the autoboxing and unboxing, because my purpose for this video tutorial is to let you know about the performance related hits related to the this task, not how the autoboxing and unboxing happens. But still, let me take few cases in real quick time. If you guys still have any questions, drop me an email or put your comments into the comment section. I'll go through that and I can explain further in other video tutorials related to the in deeper way related to the autoboxing and different autoboxing and unboxing scenario. So let's discuss the first scenario quickly. So first use case could be when you convert the primitive int to the wrapper type int, that is called autoboxing, that we have already seen in our previous slides, that the autoboxing case is to conversion of the integer int primitive to the wrapper type integer. So in this example, the primitive int 25 has been converted into the its corresponding class without injecting any other line of code. And same thing is happening for the wrapper type integer int object. It has been converted to the primitive end, that is called unboxing. So one of the scenario could be the writing the code into the primitive and assign it to the corresponding wrapper type, or do it like a wrapper type and assign that part to the corresponding primitive type. Guys, I am taking an example of integer here, but you can replace any data type, primitive data type like float, int, double, long, anything of your choice. Alright, let's take a second example now. So second example says the same scenario can be happen when your primitive types and wrapper types equal comparison happens. Like in this case, you have the integer type I1 equal to 25, right? And integer I2 equal to 25 is happening over here. So what gonna happen in the first line? You have written 25 here. It would be uh, it is a primitive type, and the second line is of the wrapper class type. So both are non compatible type. So both would be converted into the primitive int type itself. So this integer I2 would be converted into the primitive int type, and then the comparison operation would get happen related to this. So you can try it yourself into the IDE and check the answers over there. Third example could be when you would like to perform the addition on two wrapper type classes. Like here I'm adding two variables I1 and I2, and both are belongs to some class. So this is something like you would like to add two class objects itself, and that is not possible. The only addition is only possible with the primitive type. So the lines that is written right now is something like, if I say you add two employee objects, so that would not be possible. So same thing happens with the integer wrapper class also. They are actually object, not a primitive type. So you cannot perform the addition operation on them. So what will happen? First, the integers would be converted into the respective primitive types. Like unboxing case would be happen with the I1 and I2. And once you have the answer of the 10 plus 5, then that would again converted into the corresponding wrapper type integer. So again the auto boxing scenario would be happen over there. Now let's take a last example related to this. So say for an example, you would like to iterate the array list, and you would like to add whatever element you have into the array list. In this example, I have the array list of integer and I would like to perform the sum operation over there. So we already know that the array list can give you the wrapper type variable itself. Like if I want to fetch the variables, I want to fetch the object that would be that would belong to the integer itself, not the primitive type. So what we are going to do here, I would like to add primitive type with the wrapper type. So that would not be possible. What gonna happen, like I said in the previous example, that the addition would be performed with the primitive type itself. So this wrapper integer would be converted into the primitive type, then addition operation would get performed, and that would give you the desired output over there. So as of now, we have seen lot of scenarios where the auto boxing and unboxing is happening for us by default, right? We do not have to worry much about these kind of things. Now let's go to the example sets which I would like to showcase you related to the performance related hit. That would make more sense related to the this video session. So let's have a look at this program first, and I'll explain this what this program is doing, and then we will run this program into the IDE. Guys, I have created this program. Its method is very expensive, and this is pretty simple program. I have one variable long, wrapper type long here, that I have initialized with 0. And what is my use case here is find the sum of all positive integer number. So I just want to get the sum of all positive integers. So what I have done, I have written one for loop and started the index from the 0, and I would traverse it through the maximum value of the integer. That's why I have taken the condition like I is less than integer dot max value, and I'm performing I plus plus here. So pretty much simple. Then I'm storing the intermediate or temporary output into the sum variable by doing the sum equal to sum plus I. So this iteration would go on till the max value of the integer. So this is pretty simple example, and I guess you have seen it earlier as well. So no need to explain this in greater detail. But let us look at this example with respect to the auto boxing and unboxing, and then we will run the same program into the IDE and we'll try to see what are the performance related catches here. So here is the explanation of this program. If you will see this program carefully, then at this line where I have written long sum equal to the 0, so that is related to the wrapper type, and my index value is of primitive type. Now if from our previous example sets, I have said that when the addition operation is performed, the data type must be in the primitive type. Now you can see that my sum variable is of the long type, that is wrapper type, and it is okay. My long primitive variable, that is I, is of the primitive type. So I have two type of variable here. So first, in first case, auto unboxing would get happen because it has to be converted, the some data type has to be converted into the long type. So you can see here that sum has been converted to the wrapper type long to the primitive long now. Now what gonna happen to the next step? The addition operation would be performed on these primitive type, like sum plus I would get happen now. So the addition operation would get performed. Then after that, this would the result of the primitive addition would be assigned back to the sum variable, that is wrapper class. So in that case, the primitive is assigned back to the wrapper class long. So auto boxing would get happen one more time here. So this type of conversion would keep happening towards the course of this program execution. I mean, they till the max value of integer, wherever the traversing would get happen, the same scenario would be keep continue happening for this. So here is the use case with related to the auto boxing and unboxing. Now our target is to execute this program into the IDE and let us check what are the performance related catches over there. So let me jump to the IDE directly and we will further look into there itself. Okay, so I have opened this program into the IDE. Now let's have a quick look into the program here. So same very expensive method I have here, whatever we have seen the explanation into our slides. So what's going on here, the same long wrapper type I have taken here, and whatever I explained to you guys, like these lines, like some would get converted from the wrapper to the primitive types, then addition operation would get performed, and then its results would be again assigned back to the sum variables. So this iteration would be continue till the maximum value of the integer, that is the integer maximum value is 2 raised to the power 31 minus 1. We are performing the non negative values only the natural number starting from the 0. So it's like if this loop would be traversed till 214748367 times this loop would get traversed. And before the execution of this program, let's look into the one of the case which I explained, that your IDE can help you out to find out whether the auto boxing and unboxing is happening or not with respect to your program. So let me explain that part first, then I'll come back here and we'll discuss the performance related issue here. So guys, have a look at these two lines, line number 20 and line number 23. Here you are seeing one of the warning. This warning says if I hover my cursor on the warning bulb, then what it says like this. See here, the the expression of type long is boxed into the long. So it's give you the warning like you are performing the auto boxings here. Same thing happens if I hover my cursor on the line number 23. It says again that the expression of type long is boxed into the long and the expression of type long is unboxed into the long. So both boxing and unboxing is happening over here and my ID is clear cut saying to me in this way. But this thing doesn't happen by default. You have to turn on in your ID itself that you must need the warning about the auto boxing and unboxing. So to turn that on, you have to go to the help section, then Windows section, then preferences, and inside the preferences you have to go to the compiler and errors and warning section. In the errors and warning section, if you will see the potential programming problems, One of the sections says about the boxing and unboxing conversions also. Look at here, the highlighted part. These things by default set to the ignore this auto boxing and boxing, so turn it on to the warning level, so you can make it warning, then only you would see such type of warning in your IDE. Otherwise it would not say any kind of warning to you. It would be working like a smooth program for you. So I can show you that. So next time when you write any program related to the auto boxing or unboxing, you can try it out by turning on the boxing and unboxing to the warning level. So let me go back to the program. I can show you if the auto boxing and unboxing case is not there. Like, let me convert this program to the long. Then see that warning has been disappeared from here, right? So this is a really helpful stuff that you can make changes in your IDE, like you can turn on the boxing and unboxings in your program, and that is really helpful because many times we don't know by default that's what's going on with the program and whether the boxing or unboxing cases are happening or not, because we would like to check the performance also along with that. So as of now, let me revert this primitive type to the wrapper type one more time. And now it's time to run this program and see the performance hit related to this program. So before running that program, what logic I have written to find out the performance or the throughput of this program, like what I have done, I have performed pretty much simple things. I am just calculating the time performed to execute very expensive methods. How much time this very expensive method has taken to execute during the entire cycle. So what I have done, I find out the start time before executing the very expensive method, and for that I have used the system class nanotime API here, and the end time I have calculated just after the very expensive method execution, and the differences of end and start time and the divided by 10 raised to the power 9 will give me the output into the seconds, that how much seconds this program has taken to execute the particular stuff. So not a rocket science, pretty much simple stuff. Now let me run this program and we can analyze the output here. So I'm executing the program. So right now it is in execution state. It is taking some time because integer max value is really large. So let's wait for the output. Okay, here we go. So it has taken around more than 10 seconds. If you notice into the output section, then it has taken almost 10.67 seconds to execute this program. So now let me make single change in this program and rerun this, and then we will see that what happens with this program. All right. So let me convert this wrapper type to the primitive type and run this program one more time. So I'm running this program one more time, and now observe the output. Alright, we already have our output as soon as I executed this, and this time around it took only 1.5 seconds. So did you notice how much drastic change has happened during once I changed only one thing in this program? I converted from the auto boxing or the wrapper type long to the primitive type long, and my output time has been reduced by 5 times, almost 5 times. We have reduced the output. So much performance gain by changing only one thing. So how it has happened? Now one more time check this program, and we can easily analyze that how this has happened now. Before that, notice one thing which I have already explained, that in this program neither auto boxing nor unboxing is happening now. The line number 20 and 23 does not display any kind of warning now. So you can easily analyze that due to the auto boxing and unboxing steps itself, my program execution time has been exceeds by 5 times. So what going on now? What I am doing? I am performing the simple addition operation, and my temporary variable is of primitive type only, and my index variables which is iterating is also the primitive type only. So no auto boxing or unboxing is happening. Now there is no need to convert this sum into the primitive type because it is already into the primitive type. So addition get performed straight away, and the result also no need to be converted into the respected wrapper type, or auto boxing is also not needed now. So due to the auto boxing and unboxings, we have observed that if we make the small changes in our program, then the performance can be improved by many folds. So be in future, be really careful about such type of things. That is why I recommend that the warning should be turned on into by default in the IDE, because many times we don't know that the auto boxing and unboxing is happening. It happens by default and anybody can miss it easily. So in this way you can easily capture what's going on with your program. Okay. So guys, that was the performance related stuff there related to the throughput. Now let's discuss about the memory consumption part. So let me take you to the next program and we can see real quick way what are the memory consumption when we use the same program. So one thing you must be sure here, that like right now we are using the uh, wrapper type instead of primitive type to perform these operations. The same program is here also. We have long sum equal to 0L. So instead of primitive type, we are having the object type, the wrapper class of that class. So certainly the memory footprint would be far more than the integer primitive type. Why? Because for if related to the memory footprint, there are additional overhead is required to store that object into the memory. What are those overhead? Like if you want to store the primitive values into some object, the first thing comes in the header part. There would be some memory allocation related to the header in the memory. So that would be helpful for the housekeeping work related task. So few bytes would be required for that. Secondly, your field itself, primitive field itself, that would get stored. So whatever the primitive types, say for in this case the long primitive types takes 8 bytes to store into the memory. So those 8 bytes would get required to store that. Then some padding would be required in the memory. I'm writing only P here, shorthand. And then one more thing, like the reference field would also get stored into the memory. Like here, this is entire object creations and the reference is long sum here. So the reference related footprint would also be required. Something like 4 byte would be required to do such type of things. So you can see that with respect to the primitive type, only this box is required to save your program. While you convert the same thing into the wrapper type, these all things are required. So additional overhead is required to save your values into the memory when you have the related classes of the primitive type. So certainly you can see here that the memory consumption would be far more than that. So we can check it out quickly using the garbage collection stuff. We can notice that what's going on when I convert this program to the same on same line whatever we have done earlier. Like I can make it to the primitive int and the wrapper int both. So the real easy logic for this, I have taken the runtime object of getRuntime from the runtime class itself, and once I have the runtime objects, I call the GC for the garbage collection. So before executing my program, I'm running the garbage collection once, and once my program get executed, I redo the same exercise, run the garbage collected collection again. So in this way, I can easily calculate that how much memory has been used now in runtime. So before performing the program and after performing the program, we'll have to execute the garbage collection. One thing I would like to say here that garbage collection never guarantees. So we cannot be 100% sure that the output would be similar all the time or the garbage collection happens behind the scene. But that is for sure that the memory footprint would be far more than whatever we have during the primitive type. So once I get the total memory and minus the free memory from the total memory, so the used memory would be returned to me. So let me run this program now from the wrapper type itself, which has the performance issue, and observe the output. So it's again taking some time. So let's wait for the output. So here we go. It took somewhere around 13.27 seconds, and see here, note it down. You can pause it and note it down the value, and I will run one more time for the primitive log. So used memory is 310912. So just remember this stuff, 310912. Now let's make the small change into the program related to the primitive type, and let's run one more time. So see here, the used memory is quite less than earlier. Earlier was 310912, while this time around 302184 only. So certainly the memory footprint or memory consumptions was far more when we were using the autoboxing type. So guys, be really careful, and you must take the wise decision while using the autoboxing and unboxing, because it can cost a lot if we are using the autoboxing and unboxing unwisely, sorry. So in this case, like, our case was simple addition, so there was no requirement of the autoboxing at all, but we have unknowingly done this, and that was causing a lot of issues to us. So that's all I have for the day. Let me know how do you like this video. Was it informative for you or not? And if you like this video, do subscribe this channel, and if you have any questions, leave me your comments into the comment section, and I'll be happy to help you out with my answers over there. Thank you guys for watching this video. Have a great day, and I'll see you in my next video with similar interesting topic once again. So have a nice day and happy learning. Thank you guys once again. Bye.